Hello students, let's understand how to solve this question. In this question, first of all, we have to make the prime factors of the numbers which are given within the bracket. So let's start with first 1728. Now first, if I have to make the prime factors for this number, I have to divide it with the prime number. So the smallest prime number with which I can divide this number is 2. So we'll get here 2 8s are 16, 2 6 are 12, and 2 4s are 8. Then again I will divide it with 2. 2 4s are 8, 2 3s are 6, 2 2s are 4. Again I will divide with 2 and I will keep on dividing it with 2 till the time I will not get 1 at the end. So 2 2s are 4, 1, then 6, then again 2, 108, again 2, 54, again 2, 27. Now I cannot divide 27 with 2, so I have to take the next prime number, which is 3. So 9, then 3, 3 and 1. So that means 1728 can be written as 2 raised to power 1, 2, 3, 4, 5, 6. That means 6 into 3 raised to power 1, 2, 3. Now similarly, if I will find out the prime factors for 2744, I will divide it with 2. So for 2744, we will get it equals to 2 raised to power 3, 1, 2, 3 into 7 raised to power 1, 2, 3. Now the next number is 4096. Let's make the prime factors for this. So 4096 can be written as, we have to count how many times we have written 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that means 2 raised to power 12. Now we have to find out for 9216. So see 9216. If I divide with 2, I will get here 2 4s are 8, 2 6 are 12, then 0, then 8. Then we'll keep on doing it. So 9216 can be written as 2 raised to power 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 into 3 raised to power 1, 2. Now similarly, if I find out for 729, it would be 729 is equals to 3 raised to power 1, 2, 3, 4, 5, 6. Now we'll find out for 343, which is 7, 49, 7, 7, 7, and 1. So some of the factors you must know, like they are divisible by which numbers. So it would be 7 raised to power 1, 2, and 3. Now, after you will do all this calculation, now we have to put these values in terms of the exponents in place of a number in the question, and then we'll solve it further. Now let's substitute the values here. It would be negative 2 raised to power 6 into 3 raised to power 3 over 2 raised to power 3 into 7 raised to power 3, and the power which is given in the question, I will distribute it to numerator as well as denominator. Same I will do with the other fractions also. So 4096 can be written as 2 raised to power 12 over 2 raised to power 10 into 3 raised to power 2. And I will take here 1 by 2, 1 by 2, because 1 by 2 is the power for the fraction. Now I will distribute this power to both numerator and denominator, minus 3 raised to power 6 raised to power 2 over 3, 7 raised to power 3, 2 over 3. Now, since we have a negative number here, so first we will write on here negative 1 raised to power 2 over 3, 2 raised to power 6 raised to power 2 over 3, 3 raised to power 3 raised to power 2 over 3, and same we will do for the other numbers as well. Now we will use the rule here which says a raised to power b raised to power n is equals to a raised to power b into n. That means we have to multiply the powers. Now first one is negative 1 raised to power 2 over 3. Now for this, if I have to write down, I can write negative 1 raised to power 3 into 2 by 3. The reason is because negative 1, if I will write down negative 1 into negative 1 into negative 1 3 times, I will again get negative 1. So I have to get rid of this power which is in the denominator place, that is 3, with the power which will be there in the numerator place. So I have written negative 1 raised to power 3 rather than writing it as negative 1 raised to power any other number. So we can cancel it. Similarly, we'll do the value for the others as well. 2 over 3 into 3, 2 over 3. So we can simplify them like this. And we'll continue with the same for the other numbers as well. Now it will be negative 1 raised to power 2, 2 raised to power 2 into 2 over here. That will be equals to 4 into 3 raised to power 2 over 2 raised to power 2 into 7 raised to power 2 into 2 raised to power 6 over 2 raised to power 5 into 3 minus 3 raised to power 4 over 7 raised to power 2. Now, whatever the numbers are there which are having a same base, those. Now here we have to use the next rule which says a raised to power m into a raised to power n is equals to a raised to power m plus n. So negative 1 square means 1. So we will just remove this from here. So it is 2 raised to power 4 plus 6 into 3 raised to power 2 over 2 raised to power 2 plus 5 into 3 into 7 raised to power 2 minus 3 raised to power 4 over 7 raised to power 2. So we'll get 2 raised to power 10 into 3 raised to power 2 over 2 raised to power 7 into 3 into 7 raised to power 2 minus 3 raised to power 4 over 7 raised to power 2. Now after this we have to use the next formula which is a raised to power m over a raised to power n is equals to a raised to power m minus n. So 2 raised to power 10 minus 7 into 3 raised to power 2 minus 1 over 7 raised to power 2 minus 3 raised to power 4 over 7 raised to power 2. So we'll get 2 raised to power 3 into 3 raised to power 1 over 7 raised to power 2 minus 3 raised to power 4 over 7 raised to power 2. That means we'll get here is equals to 2 into 2 into 2 into 3 over, since it is 7 square, so we can just write down 49 as a denominator minus 3 into 3 into 3 into 3, which is equals to 8 into 3, 24 minus 81 over 49, which is equals to minus 57 over 49. So that is the answer for this particular question. I know the calculations are too much, but once you will understand everything in the question, you will be able to do any kind of a questions where you have such big numbers. For the prime factorization part, you can see the videos which I have already shared in the description box, how to find the prime factors of the numbers. So if you have any doubt in this particular part, you can watch the video and can clear your doubt. And I hope you like the video. So hit the like button, subscribe my channel and share my channel link with your friends and family. Thanks for watching.